Hello everyone, welcome back. Today we're going to take a look at Microsoft Foundry, Microsoft Agent Framework, and Postgres, and how we can use these three to build agentic applications. But first, what is Microsoft Foundry? And keep in mind, this video is not an introduction to Microsoft Foundry, but maybe I can provide some brief explanation. Basically, what Microsoft Foundry is an end-to-end platform for building agentic applications on Microsoft Azure, and it's a platform that you should definitely check out if you're interested in using Microsoft Azure, if you're interested in working with Microsoft products. Basically, that's what Microsoft Foundry is, and it's really powerful platform. You can build agents, you can monitor agents, you can build evaluations, you can connect agents to various services, both internal and external. You can rely on robust security that Microsoft provides built in, and you can customize it the way you want, basically. And that's it. That's Microsoft Foundry. Microsoft Agent Framework, well, that's the newest framework from Microsoft used to build agentic applications using code. So we have currently Semantic Kernel and AutoGen, both of which are great, but the idea is that Microsoft Agent Framework will take the best of these both worlds and build something better, which is Microsoft Agent Framework. And if you're interested in the Microsoft ecosystem or using Microsoft Foundry or anything related to that, I highly encourage you to learn Microsoft Agent Framework. And you don't have to use Microsoft products, but Microsoft Agent Framework is agnostic to any cloud. You can use OpenAI, you can use Microsoft Foundry, you can use a lot of different integrations. So today I'm going to show you a few use cases, really simple use cases that will give you an idea of what you can do with Microsoft Agent Framework using Microsoft Foundry and Postgres. So let's get started. I've prepared 5 use cases. Let's go over, we'll go over each one of them. But first, let's go to the first one, which is basic RAG agent. So this one, we're using an agent that we've created inside Microsoft Foundry called Mr. Monopoly. And we've added knowledge base, which is basically a file that contains the rules of the game Monopoly. Let's see that. If we go on over there and build, then models, not models and agents, you see Mr. Monopoly here. We have provided some instructions that the agent is expert in Monopoly and its only job is to answer questions related to it. It should never answer any questions related to anything else. And it should act like cool fella. And here is the knowledge base, which is one single file that contains the rules of the game. And we can play around with it using the Microsoft Foundry portal here. For example, if I say how many players are allowed in the game, it will give us an answer using that knowledge base, using that file with the rules in it. Okay, great. But if I ask what is C#, for example, it should say that it doesn't know because that's not related to Monopoly at all. Great. Now let's see how we can do this thing in code. So first we have some endpoints that connect to the Microsoft Foundry. We have OpenTelemetry here, and I'll show you that as well. And here how simple it is. So we are creating the project client and we get the agent, which is Mr. Monopoly. We create a session and we will ask a few questions. How many players are allowed to play? What are the rules of the game? And what were my previous questions? The idea behind this question is to show you that you can create a session where basically the agent remembers your whole history. Let's run this. And we start with the question. Here is the answer. Here is the answer to the next question. And when we ask what were my previous questions, it answers correctly. And here's this is from the OpenTelemetry. Now, if we go back to Microsoft Foundry under traces, for example, let's see last day. And you see, this is the latest one that we've just interacted with. Come on. Here it is. Let's click on it. And here's the whole trace of this interaction, of this session, basically. So we can go here. We see the system prompt. We see the user input, the output, and here we have a system message that user has uploaded files. And basically this lets the agent know that they can use some files to find the right answer. And yeah, here's the interaction. We can go over it. Basically, we have the whole thing here with the previous, with the last question being what were my previous questions, and the output is this right here. And that's it. Now, let's go to the next use case, which is agentic flow. So this one, as the name suggests, is using Microsoft Agent Framework to create a flow where multiple agents are interacting with each other. And this is extremely powerful pattern because nowadays the idea is to use multiple agents where each agent is responsible for one thing and is an expert in that thing alone. In this case, we have 5 agents: the business analyst agent, tech lead, developer, QA, and change report. And the idea behind this simple application is that we provide some idea, a business case, to the business analyst. The business analyst summarizes it and gives it to the tech lead. The tech lead creates the technical requirements about the implementation and gives that to the developer, who will develop the solution based on the tech lead's guidance and the requirements. Then the QA will check what the developer did. And then the last one, change report agent, will basically give us a short report in a tabular format. And here we create the flow and we ask implement clean architecture. And in there, the flow will start with this. Let's take a look. Okay, so we have the business analyst, which says as a requirement that we need to adopt clean architecture principles within the system or project design. Then the tech lead starts writing down the technical requirements here. Once the tech lead is done, all that is given as a context to the developer, who start writing basically the code based on those requirements. Then the QA checks the implementation. And the last step is the change report agent, which basically gives us a tabular view of what steps we had, who was responsible for each step, and what was the outcome. And that's it. And now, if we go back to Microsoft Foundry, we can go to agents. And if you click on workflows, you see exactly the same thing that you can do, but inside this Microsoft Foundry portal. So let's take a look. So you see the whole flow here. We have the BA, tech lead, developer, QA, change report. You can add agents here or different things. It doesn't have to be agents. You can remove agents. So let's, for example, take a look at each of these. You can play around with it. But the most interesting thing is you can click on preview here, and you can say the project needs to implement clean architecture. And you see the same thing that we saw in the console application. So the BA starts writing the requirements, then the tech lead writes down the technical details of these requirements and gives that to the developer, who will develop the implementation. Then the QA will check that implementation, and then the change report agent will print the report at the end. And that's it. It's pretty cool. Okay, next, let's see next requirement, next use case, which is number 3. Here we will be using Postgres to store our chat history. And in here, I'm using test containers, pretty useful NuGet package, with which you can create containers locally. And I will use a containerized Postgres database. Then I'll create a table called chat history, where I'll put the message, the role, then I'll again use the Mr. Monopoly agent. So as you can see here, I'm getting the agent, creating a session, and then I'll start chatting with Mr. Monopoly. Let's see that in action. So here we are starting Docker container, and chat history has been created. So now we can ask the same questions. So how many players can play? Okay, we get an answer. But if I say, what is BMW? And it returns that it doesn't know, basically, because it's not related to Monopoly. And now, before I close this, I'll show you how you can easily see what happened, for example, in our case here, using pgadmin. So we'll connect to the Postgres instance. But first I need to see what is the port of this. Okay, so it's this one. Let's now connect. And here's our local Postgres database. We go to schemas, tables, and here's our chat history. Let's see what we have. And here is our chat history, basically using Postgres as a data store. So here's the question that we asked, here's the answer, and yeah, that's pretty cool, right? Okay, next, let's see what we have. Fourth use case. So the fourth use case is about using Postgres for RAG. What is RAG? Well, RAG is a way to add additional context to your prompts so that the agent or the LLM knows a bit more information. Because the LLMs, as you know, they are trained with data that is up to a certain point, for example, December 1st, 2025. And if you ask an LLM a question that is related to something newer than that date, or something that is private to you or your organization, then the LLM cannot know, it doesn't know, because hasn't been trained on that data. So one way to fix that is using RAG, which is basically a database called a vector database that holds something called vectors, which are just a huge list of floating point numbers that mathematically work so that you can convert text to a certain combination of these floating point numbers. And whenever you ask a question, so first of all, you add the knowledge that you have. For example, let's take as an example Mr. Monopoly that we've used. So initially, I also used RAG for the first example, but that was built into Microsoft Foundry. So the only thing I did was I uploaded a file that contained the rules of Monopoly. And behind the scenes, that file was converted to vectors. And these vectors were stored inside a database, a vector database. So whenever I started asking questions, so behind the scenes, we are converting the question to a vector, and then using semantic meaning or semantic search, we are asking, is there something in the database that is semantically similar to what our question is? And then we retrieve that, we add it as a context to our prompt, and then we ask the LLM, and that's how the LLM knows about how many players are allowed to play Monopoly, for example, because that's part of the context now. Okay, so let's take a look at this example. We have an embedding model that I can show you. I've deployed that model in here. Here it is. And basically what this model does is it's converting text to vectors. So this huge list of floating point numbers that I told you about. Then we have the agent called RAG agent. Here it is. And then, again, we are creating a Postgres container. We are seeding data, and here's our knowledge base, basically. We are using this array of strings that contain some information. And here's the schema. So we have content and we have embedding, which is this vector that I told you about. So a list of floating point numbers. So in here, where we are seeding the knowledge base, what we do is we go over each of these elements inside this knowledge base and convert it to a vector. And we store that as part of, as well as the content. So we're converting, for example, we're converting this whole thing into a vector, but we're storing that as string as well. And then we just we start looking for semantic meaning here, and you see that in action. So whenever we start interacting with this chatbot, it will search. First, it will convert our question into an embedding or vector, and then it will ask here the Postgres database to find us something that is semantically similar to our question that we just embedded here as a vector. And that's how this works. Let's see that in action. We are again containerizing Postgres locally. We're seeding the knowledge base. And now let's see. We can ask about C# here because I know that we have information about C# here now. And what it does is it's converting this, as you can see here. Here is our question. So it is converting it to a vector, and then it's searching, the database is searching for closest match, semantic match to that question. And since we have information about C#, programming languages, it knows that this is the correct answer. But if I ask what is BMW, we don't have any information about BMW or cars. So it should say that it doesn't know, which is correct. Now, let's take a look at inside the database to see what we have. First, I need to disconnect because this is no longer relevant. It's using the old port. Let's use the new port now. Okay, connect. And here's our database again. So here's the RAGDB. Let's go to schema. Here's our documents. And here is the content. So each of these strings that you saw in that array. And here is the embedding for each one of these. And here's what a vector really looks like. Okay, now let's go over to the next use case, which is basically the same as this one with one difference. For this one, we're using instance of Postgres from Azure. So it's not deployed locally in a container. We're using a Postgres instance on Microsoft Azure. And let me show it to you. Here it is. It's called Azure Database for PostgreSQL Flexible Server. Okay, that's a mouthful. But the idea is exactly the same, and the implementation is pretty much the same. So we have the embedding model, the agent. Here though, we are connecting using token, and the rest is exactly the same basically. We're using the same knowledge base. Let's run this. And now let's ask what is C#. Then what is BMW? And we get the expected results. Now, how can we see that on that Microsoft Azure Postgres instance? Well, one way is using the Postgres extension from Microsoft using VS Code. Here it is. Now let's check it out. Here's the documents table. Let's query it. And we see exactly the same thing, but this time using a Postgres instance from Microsoft Azure. And that's it, guys. I really hope that this was useful to you. If you are interested to learn more, I mean, you can learn more regarding Microsoft Foundry using their official site here. If you're interested in the Microsoft Agent Framework, again, you can use their own Microsoft Learn pages here. And yeah, that's it. I really hope this was useful. If you like this video, make sure to like it, subscribe to the channel, share this video with your friends or colleagues, and I'll see you next time.